All right, so now I'm going to add to what I did before. So before we just counted like the number of integers that were multiples of 4. Now I'm going to be doing multiples of 4 or 7. So multiples of 4, number of, numbers that are multiples of 4 or 7. So I'm going to have the multiples of 4, the multiples of 7, and I'm going to have to subtract off the numbers that are multiples of 4 and 7, right? Because I've counted them twice. Okay, so let's look for multiples of 4. So multiples of 4, so they're starting from 1 and going up to 100. So I'd have 4 times 1 all the way up to 4 times 25, right? So I want to count the number of numbers between 25 and 1. So I take 25, subtract 1, and add 1, so there's 25 of them, right? Okay, so now I want to do the multiples of 7. So I'd have 7 times 1 all the way up to, and you get to 7 times 14, and that keeps me below 100. So how many of them are there? 14 minus 1 plus 1, so there's 14 of them. And then I want to find out how many multiples of 28 there are, because that would be 4 times 7, and that's what I'm going to need to subtract, right? So I'll have 28 times 1, and I only go up to 28 times 3, so there's 3 of these. So therefore, I would have 25 plus 14 minus 3, and that would give me 36. All right, so this goes all the way to 1,000. So I'll let you play with that one. And these two as well, to make sure you really get it. All right, so now let's move on to combinations. So here, combinations, order does not matter. So putting people on a student council, right? Just people in a committee, people in a group. So I've got so what this is going to be is the combination, and the way it can be written is n choose r, like this. Sorry, this kind of look the same. N choose r, or combinations n choose r. So it's n factorial, the number of them, and then I'm taking out the multiples, r factorial, n minus r factorial. And you can just leave your answers as n choose r as well. Okay, so if I have 15 students, and when I want to choose a committee of 6 people from the 15, that would be 15, choose 6. And this is a fine answer like that. And just if you wanted to figure out what this was, this would be 9 factorial, and then, 6 factorial. But this is a fine answer, just like this. Okay, so let's see what we got here. So we got 2 council members who are the same major, and they're not allowed to serve together. So what we want to think of is, we want to have one of them, so like A, but not B, or the B person, but not the A person, or neither A or B, right? If these 2 people, 2 council members, they're not allowed to serve together, it doesn't say that either of them have to serve, but I can have one of them, or the other, or neither. So or is addition, correct? Yes. Okay. So if I have A and not B, okay, so I've got 15 people to choose from. I'm choosing A, and I'm not choosing B. So out of the 15, there's 2 that I'm eliminating, correct? So I really only have 13 to choose from. And then I want to choose a committee of 6, right? I've already chosen A, so how many do I have left to choose? 5. Oops, it's a messy 5. There we go. A 5. A very messy 5. Okay. That would be the same scenario for here. I've chosen B, but I'm not going to choose A, so that means I have 13 left to choose from. I've already chosen B, so my committee of 6, I've already chosen one of them, so I only have 5 left to choose from. Okay, so now, not choosing either one of these 2. Okay, so if I'm not choosing either one of these 2, out of the 15, I've eliminated these 2, so I only have 13 to choose from, and I'm picking 6 for the committee. So this would be my answer. Okay, Now, what you could do, I want to make sure you see a different way to do this. What we could say is we could find out the way to find all the ways, and we could subtract off choosing both A and B, right? So what are all the different ways that I could, out of the 15 people, choose 6 for the committee, and I could subtract off choosing both A and B, which is what I can't do, right? So out of the 13 left to choose from, because I've chosen A and B already, I've chosen A and B already for my committee of 6, that means there's only 4 more to choose from. So these two numbers turn out to be exactly the same. And I actually figured it out. So 4290. So this is 4290. So every so often you can kind of double check your work by computing it. And let's just finish off one more of these, right? Okay, so 2 council members insist on serving together. Or they won't serve at all. Okay, so you can have both or neither. Okay, so if I choose both of them, so on the committee of 6, I only have 4 left to choose, and I've already chosen both of them from the committee of 15 people, there's only 13 left to choose. Or, okay, I don't choose either of those 2. So out of the 15 people, I've eliminated 2, so there's still 13 people to pick from, but I still need my committee of 6, so I pick 6.